Hello everyone, welcome to Troy the new era of learning. This is Pack 365. Let's move into the topic. In today's Model 2, in this section, we discuss about breadth first search algorithm in AI, Part A. Let's move to topic. We all know about BFS, right? BFS breadth first search on algorithm in AI, right? So, BFS is a graph traversal algorithm widely used in artificial intelligence AI for tasks like finding the shortest path in unweighted graphs and exploring such spaces. It explores a graph level by level, visiting all the neighbors of the nodes before moving on to the next level. The systematic approaches makes BFS suitable for various AI applications, right? So we can say that it is a fundamental of uninformed search algorithm used in artificial intelligence to explore the nodes and nodes like we call states of a graph or tree level by level. Okay, so BFF starts at the root node of, or any attributed node, and it explores all the neighbors nearest neighbors nodes first before moving to the nodes at the next level, right? So BFS travels of a graph produce a spanning tree has finished result. Spanning tree is a graph without loop. We use quiz data structure with maximize size of the total number of vertices in the graph to implement BFS travelers, right? We use the spanning tree also because it does not form any loop. If we visited one place, it could not uh, form a loop cycle, right? So it avoids the loop cycles and it use quiz data like we use quiz data is nothing but it's first in first out like that we use the data. So working of behavior. So let's start with the steps how it's working. So obviously we have few steps to run the BFS. So from the step one, we can see define a quiz of size total number of vertices in the graph, right? So it accordingly the queue of size of total number of vertices in graph. Means a queue is nothing but FIFO. We all know about the FIFO, first in first out, right? So it usually used to keep and track the which travels like which vertices to explore next first in first out. If we stage one destination spot, we want to think the next destination spot like nearest destination spots. If we have A and B, C, the nodes connecting with A and B with the first destination, we pick up the two. If it existed, we moved that like we use choosing the quiz. So step two, select any vertex has starting point from the traveler, visit that vertex and insert it into a quiz, right? So, right, pick a vertex to start a travel. So, like we pick any starting point, make it as visit and increase with right. If you visited that at vertex, then you have to choose next vertex like this. This is an entry point of the Bitford search. We wherever we pick up some starting point, it is the entry point of the BFS. Step three: visit all the non-visited adjacent verticals and of the vertex which is at forefront of the queue and insert them into the quiz, right? So this all about so check the vertex at the front of the queue, right? For each adjacent vertex that has not been visited like that. So make it as visited and ensure that to explore the later next. So next is step four, when there is no new vertex to be visited from the vertex which is started from front of the queue, right? Then delete that vertex. So step four is nothing but if all the adjacent nodes of the front vertex and or visited, like remove the vertex from the queue. Okay. So this means you are done exploring the that all nodes you have already explored. So stepwise nothing but repeat the steps three and four until the quiz become empty, right? So we repeat the step four until we returns like continues the process like visiting the neighbors, make them as visited, enqueue them, and remove the current node after it neighbors or proceeded. Stop when the quiz is empty, right? All the reachable nodes have been visited. And final step, when the quiz become empty, then produce final spamming tree spanning tree by the removing the unused edges from the graph. Like once traveler is completed, if you are building a spanning tree, remove the edges, not part of the BFS traveler path, right? So the result is a BFS spanning tree that connects all the reachable nodes without circuit, right? Does not form a circuit. So the concept of we can say that all vertices are visited in the level by level manner, and the short part is that in terms of the number of edges it found from the source to each vertex, a spanning tree is generated if the graph is connected properly. So now let's do example. Let's move to the example. Uh, in this example, we can see consider a following example graph performs like BFS traveler. So we have a graph called we have a set of graph. We have a vertex like A, B, C, D, E, F, G. So from the starting point, step one, right? We are doing example. Step one, select the vertex A. It is a starting point of us. Okay. So visit A, insert A into the quiz. We enter the A. We visited in A. We want to enter into the quiz like first in first out FIFO. So we enter the X A here. After that, we can see there. So after that, we can see here. So we can see here we have a text here. It is our entry point here. It is here we have entry point, right? So how many vertices connected with A? Like we have A, we have D, we have E, and we have B, right? B, D, E. We have connected with A. So, what we want to did like if we have three connections, we want to enter here. Like if you have B, I want to move with B, D like that. I want to make sure that what vertex is next, right? In case what you want to do, I can enter here. I can enter here B. I can enter here D. I can enter here D, E. Right? Like that. I want to move my vertex to forward. Okay. So. So moving to step two. In step two, we can see that we already said visited all the adjacent uh, vertex of the A which are not visited, right? Which are not visited. We can see the D, E, B, right? We can say that we can take not only D, B, A, we can take from we can start from the B, we can start from the E, like we it's want to take how many adjacents are visited with A, connected with A. So insert newly visited vertices into the quiz and delete A from the quiz. Like we want to delete the A again. And now next quiz is D. Like we want to moving D. We next step we move to the D. Right? Next step we move to the D. After that, from D we removed A. Right? Visit all the adjacent verticals of D which are not visited. There is no vertex. Right? We can delete D from the quiz. Like after finding the path. D, we do not have edges, right? We have only A already we visited, we deleted, and D, now we want to reach E. Then we can delete the D. And step four, we almost entered E, right? From E, we have B, C, D. Here we can say another, if we have here one another conclusion here. So, if we enter, we can see here, firstly, we start from A to D, and we didn't for from A to D we started. Then we have no more vertices from the D. We have only one E, and we traveled for E. And now we removed A, and now we deleted D because we already visited it. And now we for reach to E, right? From E we have we have B, we have C, and we have E, right? So now the point is we already visited in this we have how many quiz we have B, C, F, right? So if we deleted E, we want to move C or B. because already in the term of we existed B, right? Already B is existed. So we doesn't consider B again in the quiz. So we start with C directly. C, we enter the C and F, right? You can see here. So we can see if we visited C, we deleted the previous graph, we can see that. So we have EB, but we didn't enter B again because already B is existed. So we entered just C and F. So from the graph 5, visit all the adjacent verticals of B and which are not visited. There is no vertex, right? So delete B. We did not consider B, so delete B. Let's move to the C. From C we have F and G, right? We have F and G. So we enter F and G for next step. So we removed C again, visit all the adjacent verticals of the C, which are not visited G, right? Which are not visited G. Insert newly visited vertex into the quiz and delete C from the quiz, right? We deleted C and insert F. See, like that. The final, we reach the final step. How many we travel from, like we travel from the edges like A to D, D to B, like that. We travel the edges, right? We cover all the edges and we return back to the D. If the adjacent close, we carried B, but we didn't consider that route and we returned back to the E. Then we considered C. Delete F from the quiz, right? Now final output is like this, a graph. So at the edge of E, we can have empty quiz. We have visited G also. So like this, step by step, we all visiting all the vertex. The concept of BFS is nothing but visit all the vertices possible way, but we did not want to form a circle, right? We did not form a loop. That's why we're using spanning tree. So we can say that see here, here we travel, here the loop of we can see here it travels like this. We can have here we didn't receive, either we didn't form loop here we didn't form any loop, here did not form any loop here also. See, we didn't form any loops here. It's cover all the vertices, right? From it covers all the vertices. Like we can see here. So it forms here to here. We can form a loop like this. Like it doesn't form any loop here, right? So even through here also doesn't form any loop here. So like that it works. So we doesn't want to form any loop. We want to cover the vertex. Okay. So the outcome is like this. See, with the quiz become empty. So stop the BFS process. Final result of the BFS is spanning tree. Has shown the so we can see here we doesn't form any loop here. We've covered all the vertices of the graph. So I hope you guys are all understood about the topic of that BFS. In part B, we have discussed a little bit more about that. So thank you for all. Thank you all.